Welcome to another Ben tutorial. In today's tutorial, we're going to be making a merge sorting algorithm. Now, merge sorting is a much quicker way to sort some list of whatever you want, rather than using something like a bubble sort, which is incredibly slow, which uses big O n squared notation. This will be using n log n notation. So we'll start by making our method name and everything, and we're just going to give it a list of integers, and we're going to get back some list of integers as well, but this will be sorted. So let's just call it merge sort, and we're going to give it a list of ints, and we can just call that list for ease. First thing we want to do is make this little idiot proof. We can say, hey, if the list is less than or equal to 0, we can just return it because it's already sorted necessarily. So once we got that out of the way, we can actually go on to making the list itself. So the first thing we need to do is, because the way merge sort works, we need to make a front list and a back list because we're going to be dividing the list into halves. And this is going to be recursive, so we're going to be calling this method on itself over and over and over again until it gets down to just base pairs, essentially. So let's go ahead and make those. Let's call this one front, and that'll be another list of ints. Then we're going to make another one called back. And then we need to find the middle of the list that we're given. So we can just go ahead and make an int. We'll just call it middle. And we'll say list.count divided by 2 will give us that. And since this is using integer, it'll lop off if there's a decimal, and it'll round down at that point. So first thing we want to do is add a bunch to the front of the list, and we're going to split it 50-50. Add to the front of the list, and then add the back half to the back of the list. So we'll say ni less than 0 because we're just instantiating that. Ni equals 0. So we instantiate that I. This is just a common for loop, and we're going to do this as long as I is less than the length of half the list, essentially. And then we're going to just increment I at every point. And each time that happens, we're going to add some, we're going to add it to the front. We're going to add the list where index is I to the list. And we're going to do the same thing just for the rear, but this time it's going to be the same int I because we're going to start at the middle of the list. And we're just going to add this one once again to the back, or dot add. Oops, sorry. Back dot add. I was wondering why that looked wrong. List I. Alright, and like I was saying before, this is in fact recursive, so we're going to call this, our merge sorting algorithm, on itself over and over and over again. So we're going to call merge sort on the first list, and we're going to call it on the back list. So so this will get everything down into like its base pairs, essentially. And then from that, we need to make a new method. We could make it in here, but it's prettier and a lot more fun to not if you make it outside of it. So we're going to make a private static method, and we're just going to call it last merge, or whatever you want. And oops, I forgot to add the return type. It's going to be returning a list of ints, obviously, because that's what we've been handling everything with. And we're going to hand it in our front and back list. So we can just make 2 lists of ints here that we're handing in. We'll call one front, and then we'll make another list that we're handing in and call it back. And then we're going to be returning a result. So, and our result this time is going to be a list of ints. So I'm just going to go ahead and instantiate that. and I'll just call it result because it's easy to keep track of. And then we can start actually working on the method itself. So I'm just going to use a while loop here because we don't actually have to keep track of anything. We don't have to count anything. So we're just going to say while the front dot count is above 0, or, and this is really important, or the back dot count is greater than 0, because this allows us to use this both without splitting out into two different while loops. Alright, so the first thing within this while loop, we're going to go ahead and check and see if the front list so the first thing we're going to do in this while loop is we're going to check and see if the front list is above 0 and if the back list is above 0. So if I say front.count is greater than 0 and the back.count is greater than 0, we can go ahead and run whatever we're running this if block. But before we start writing that, we should take care of our easier solutions, because this is going to have the brunt of the situations in it. So we can say else if the front count is greater than 0, but not necessarily the back count, we can go ahead and run this one. And all this is going to do is add the result that, or the integer that is the only integer in the front list to our result, because it's the last one in there. So we're just going to do result.add, and we're going to do front.first. And for this, I'm using Linq because Linq is great and it's being used up here. So if this doesn't happen immediately, that's something you'd need to be using. And since we've added this, we should also remove it. So we're going to say from our front, we're going to remove this front.first. And then we're going to do basically the same thing for the opposite situation. So if the back.count is greater than 0, but the front.count isn't necessarily, we're going to go ahead and do, oh boy, that's some good formatting. Else if, okay, much better. We're going to go ahead and do the same thing, but to the back list. And then we're going to go ahead and remove it from the back. Alrighty, should be good to go. Now we can start with the brunt of the work, which will be happening in our first if, because this is where most of those cases that are coming through the list is going to arrive at. But really, all we're going to be doing is checking to make sure that whatever numbers in the front of the list, in the front of the front list or in the front of the back list, is greater or less than the numbers being compared to. So we can just check and see if front.first is, let's go with less than or equal to back.first. We can add that to the front list, or to the result list, I mean. We're going to add the front list, is what I was trying to say, that position, the first position there, to that front list. And then we're going to remove it from the front list. And then we're going to do the exact opposite if it is not the case. So we're going to say result.add back first, and then back.remove back first. All right, and that's pretty much it. Once we're through this while loop, we can go ahead and return a result. And in here, we can now call that last merge and give it these two merge properties we have, these two merge lists we have right here, the front and the back. So we can just say return last merge, front and back. And that's it. There's your merge sort method. I'm back and I went ahead and made a few changes here. One of them is I added a bubble sort list down here. And you can ignore this for now, that's something else I was working on. And then I made a CLI so that we can kind of have an idea of what's going on. And this will allow us to pass it a bunch of random integers in a list. And so we can actually see how much quicker the merge sort is than the bubble sort. So let's go ahead and run that. Let's make it, I don't know, 25,000. So as you can see, the merge sort took 61 milliseconds, and the bubble sort took almost, well, over 3 seconds.